you will see the branches here in the UI. In this case, I can't press approve because I'm the author. And now what I do is I do rebase. Still, you understand what is happening here, right? And it's easy to review. And then next thing is let's create a repo. Hello. Today I'm going to tell you about Git. I will tell you about what Git is and how to use it in general. I have a plan for this talk, so I will show it to you. The majority of things will be helpful generally to people who just want to work with Git in any context. First, I will tell you about what is Git and how is it used, what is it used for. Then how to work with it, several hints and things from my experience. Then show you how to create a repo, a new Git repo in GitHub. Then show commit flow, how you do the commit, explain what the commit is. Then we'll show you how repository looks from another user. Then we'll explain you things about branches. Then we'll explain you specifics of merges, like what are the conflicts, when they appear. We'll show you rebase. We'll show you how to do merge in main branch or in master branch and explain you merge requests or pull requests. Then we'll tell you about tags, stash thing, and in the end there will be a bonus. I will tell you about my experience of how I store Jupyter notebooks in Git. It's actually possible, not super convenient, but with some best practices you definitely can do that. And also in the end I will tell about some more advanced concepts. They're not super advanced, but more advanced than previous ones, and this will be the final part. Okay. First thing, what is Git? Basically, it's a system that allows you to store your code with the history of changes. It fits code, but also it can be used for other textual data like documents or other things in textual form. It can work for notebooks with some limitations. And you can also store binary files in Git, but with some nuances. I will tell you about them in the future. And basically, the key use cases that Git allows you to do is to store the information, to roll back the state of the, let's say, code to the previous state, for example, before some bug appeared. So you will be able to see like what was before, what was after, and for example, isolate the bug. You can see who did what. In Git it's called blame, like to understand like this particular piece was added by whom and when. Not necessarily just to blame a person, but probably to ask a question about it. Then Git allows you to develop same code base in parallel by multiple people, which is really important. And also you can review changes. So we call these pull requests or merge requests. So Git provides a great ability to review the new delta so that people are aware of who did what and why this change is made, and also this improves the quality of the code. Okay, so I will highlight already discussed things with green so that you and me will have a notion of progress. Next topic is how to work with Git. So I personally recommend to start working with Git using good client. It's actually possible to work through console, but it's better to find a good UI client, and I personally use Fork, which I find great. I will provide a link to that in the description. There is a trial version of that, and then it's paid. And I paid for that several years ago, and I actually am very satisfied with this tool. It's great, and it's available for Mac and Windows. And everything you can do through UI, you can do through console, but I recommend you to learn console commands later if it will be needed. I know the majority of console commands, but I don't use them, like probably use once per month or so. Okay, and then next thing is let's create a repo. We'll do this in GitHub, but actually there are different other systems of where you can host repository, for example, GitLab or many others. So I will use GitHub as it's quite familiar to many people. I will do this in a separate repo, in a separate project. So it will be a Git demo. I will make it public. Will not add anything. Okay. So here is it. And now what I need to do is I need to clone the repository. So clone means that I get a copy of this repository locally on my machine. Okay, and there is some basic information here how you can do this through console, but I will show you how to do this through UI. And basically, when you clone a repository, there are two options of how you can clone. For me, this concept was not super clear initially. So you can do this, you can get a URL to repository through HTTPS, and in this case you will authorize via user ID or username and password, or token as a username and token string as password. And if you use SSH URL, it looks a bit different, and in this case you authorize via SSH key. So both options are available on GitHub, and you can get more familiar with them in the future. But if you start working with Git, I recommend starting from HTTPS and then try SSH. But if you're already familiar with SSH, okay, just use SSH. I will use this one, but it doesn't matter actually. The repository will be the same. It's just a different authorization scheme. And for me, when I use SSH, I will just clone it without authorization, like without explicit authorization. I would not need to provide any password or anything, because I already have my key stored. In case of HTTPS, and if you do this for the first time, you will need to provide a password and username. And on GitHub, you do this through token, so you can just read about it. So what I do next is I go to my client with a copied URL, and I press clone. And fork already puts the URL from the buffer here, so it's already pasted. And then I select the folder where to put where to clone this repository in. So I go to the prepared folder. Okay, let it be here, and then I will provide a name to it. For example, git demo user1. So I will later clone the repository from user2, so that's why I put this user1 here. Do that. Oh, there is some error. Okay, let me see. Oh, wrong. It seems like I modified the URL instead of the folder previously. Yeah, it works now. And what I can do now is I can look at all commits, and there are no commits initially, so I intentionally created an empty repository. And in Git, there is a best practice that you create an initial commit with the name of initial commit. So let's do that. But before, let's see if I have done everything about GitHub. Okay, yeah, I've done it. So now I want to show you the commit flow. And in order to do that, I will open the folder in some editor. I will use PyCharm for that, so that I will be able to create files and edit them easily. You can use another editor if you want. So here is it. Okay, and PyCharm already added some automatic file for me, but I will create another file as the first one. So I'll just create an empty file first, like that, and commit it as the first file and first commit. So what I will do now, I have unstaged file here, which means like files that have some changes and they are on disk, and Git sees that they are different from what it is in the repository. And for fresh repository, all the new files will be displayed here. And in order to commit the file, I do the following. First, I press stage, and the file with its delta, oh sorry, I will unstage main, so I stage only empty file. And now this file will be added to the commit, and this one will not be added for now. So this is unstaged and this is staged. In Git console, it's called git add. So when you do git add, you basically stage file for the commit. Now I provide commit message, so same. I will provide initial commit and commit the file. So here is it. Now I have one commit here, and I see what files are added. If there would be multiple, I would be able to click through them and see the delta. And now this commit presents only locally on my computer, and in order to deliver it to the remote repository, I do push. So I do push. It asks me what branch do I want to push. I will tell you about branches later. So it will be the default main branch. Yeah, I just press push. And what I see now is that here I had main branch only, and now I have origin main branch, which means that my changes are pushed to the remote server. So I will tell you about branch and remote branch a bit later. But at the moment, my changes are delivered. Again, so what I did is that I staged some changes, provided commit subject, pressed commit, and then did push. Right? So stage, commit, push. And in this case, your changes are delivered to the server. That's what you do. Okay, let's see what was in the plan also. Yeah, this thing that we have here is called a commit or a revision. So I will make one more change so that you will see that how two revisions look like. So I will end this hello world commit. Okay, and let's see what it looks like now. So now I see a line already with two commits or two revisions. This is the first one, this is the second one, and they are connected, and later revisions or later commits are above here. And I see who did it, like what is the hash of the revision and when it was done. Okay, so what about that? And in Git, you easily can store text information, and it stores only the delta of each consecutive commit. So for example, if I will add one more line in this main file, for example, I'll let print by, for example, now by. Okay, and now if I commit this thing, only I want to buy something, I don't know. Okay, so if I do this in Git, it won't be like the entire version of the file is stored again. Only the delta is stored. So that Git stores changes in quite compact way for textual files. So only this delta will be saved. And if the file is big and you have changed only one string, it will just save a small piece of information that in this place this line was added, and that's it. And it happens for textual files only. For code files, for documentation files, but for binary files, like for example parquets or images, the file is stored entirely. And even if you have changed one pixel in the binary file, the entire binary file will be re-uploaded to Git. And it will take twice as much space. And the more times you change the binary file, the more space it would take in Git. And it will take both space on a remote server, which is not that important in case of GitHub if you don't overcome its limit, and it will take space locally. Because when I work with Git, everything that I see here is stored locally on my computer. So I have all these changes locally, and if I want to change the revision, I can do this without any connection to the remote server. Okay, told you that. And if you want to store lots of binary files or big binary files, you better store it in Cloud Bucket or in DVC or in other system that is suitable for binary files. For small files or small amount of big files, Git is okay. So, showed you that. Now let's see what this repository looks like from the second user. So I will just clone it again in a different folder to simulate the look, the view from another user. So I'll do this like that. I'll again go here. Okay, and where is it? Oh, it was here. Okay, so I'll put it here. Demo user 2. Now you may see that in fork I have tabs for each of the repositories, and if this will be different users, they will just have these looks on their different machines. Okay, and for now, they have the same look just because second user has pulled cloned the entire repository without any changes from other user yet. But now let's see what will happen and what will second user see if first user will change something. So let me show you. So for example, I will add one more line here, and this change is shown in first user repository because I did it in that folder. So I stage it and commit. And before I push, I see the following situation. The remote branch is here, I haven't pushed yet, and local branch is here. And second user doesn't see anything. And in order for second user to get remote changes, we do fetch. So fetch means that we get changes from remote, but don't change anything in local branches stage. So we don't modify files that are in the folder yet. And second user doesn't see anything for now because I haven't pushed the changes. But if I push them, let me do that. Okay, it's pushed. When I fetch, I would see the change. And good clients provide you an ability to do automatic fetch. So there is a setting here, automatically fetch remotes automatically. And it would do the fetch at some moment automatically, and I would see remote branch to be updated. But I would do this now just to not wait. See, so when I have fetched, I see that remote branch has a different state, but at the moment this bold thing means that I'm here and my local files represent this state, right? And I can actually check it. So I will go to user1 repo and see this hello again, but in second user repo I don't see it, right? And if I would change my local state to here, I do this by double click in fork, check out. Okay, I would see that second user repo now contains this hello again thing, right? Okay, so yeah, I've shown you that. Let's see what we have next. So yeah, we're speaking about branch. Now let's speak about local and remote branch. Local branch in a client is shown like that. You just see a name, but remote branch has, by default, it has this origin / branch name, which origin means the name of the remote, and default remote, or remote in this case means GitHub. Default remote is called origin, and then you see local branch like that and remote branch like that. And if you have made the change in the branch and pushed it, then your local branch will be in the same state as remote branch. But if you do commit, let's do this one more time. For example, I will add like this friend line here. So now I go to user one, commit it, and now I will see that let me switch to this view, branch view. Okay, so I will see that my local branch is ahead. So I haven't pushed my changes yet. All right. When I push, remote branch will be set to the state of local branch. Right. So I push, and remote branch now is in the same state as local one. But for second user, after I fetch, I will see that remote branch is ahead now. The second user hasn't updated his local state yet. And when second user does pull, he updates the local state to the remote branch. So that's the difference. Local one is what you do locally. When you push your changes to remote branch, and when you pull your remote changes to your local branch. That's it. Okay, yeah. Branches are basically needed to show you the history of changes, and there might be multiple branches. I will show you later how you do that. And you can switch inside the branch to different states, and I will show you how you do that. So, for example, if I double click on this commit, I will switch to this state. And in Git there is such thing which is called detached head, and here I see it as head, which means that I have changed my state, but I'm not on any branch at the moment. I don't have a branch tag here, branch label here, sorry. I can actually reset main branch to here, so in this case it won't be detached head by changing of the main branch state. I do this like that, reset main to here, and if I do hard, then I will just reset main branch here, local main branch to here. Remote branch stays where it is. If I do push, I will get an error because it would say, okay, your local branch is you cannot push because your local branch will override the state of the remote branch, which is not allowed by default. And in order to push such a state, I will need to do force push. So I will override the remote branch state, and it will be reset to this state where I have local branch for now. I won't do this basically, but showing it to you that you know how it works. Now I can again do pull, and my local branch resets back to the state of remote branch. Okay, so you change this local state by double click on revision if you do this in UI. And yeah, I've told you that. Okay, let me show you feature branches now. So what are feature branches? In Git, there are some like main or common branches. In GitHub, the first common branch is called main. Previously, it was often called master branch. And common branches might also be like development, which is current development state where everybody puts their changes after the work is made, and then development is merged into master. And there might be a couple more common branches, but quite often you have just one common branch, which is main or master, and then you create feature branches when you develop something new. I will show you how to do that. So I will create a separate branch, for example, for a new piece where I will say hello and excuse. And it's shown like that here. So I have this branch here. Actually, it's in the same state as main for now. But if I will commit something, I will commit it to this new branch because it's selected as bold. I see that I'm at the moment in this branch. And let me show you what it will look like. Okay, so I have this delta, and I will commit it. And I will again push it. So now I have local branch here. The remote branch is not yet created, and when I push, I will see here that this will be a new remote branch. So yeah, I do this, and this push creates a new remote branch. And when I will fetch changes from second user, I will see such a situation. So I am on main branch at the moment, but I see that there is a new remote branch like that here, right? Now I can make more commits here. For example, print a new line in the hello and excuse. So usually you provide meaningful summaries in the commit message. For now, I just skip it for the sake of time. So I have feature branch with 2 commits already, and in the same time, second user may develop something for himself or herself. So I create a new branch here, my feature, and develop it in parallel and pushing it in parallel. Let me show you what it looks like. Oh, sorry. Open second user also. Okay. And second user may decide to change something here. For example, remove this hi in the first, right? In the first message. So I have this change, okay, my feature, and yeah, committing it, pushing it, and let's see what we'll have. Let's look from the first user. So first user sees that here we have a fork, like main remains here, I'm developing this thing and another user is developing this thing, right? And once something is ready, we do merge. I will tell you about merge in a minute. And yeah, there is a way for you to see, to switch to a different branch. For example, user 1 may change his branch like that. Just double click on another branch and just do it. If you don't have any local changes non-committed, it's super easy. And if you have local changes, you can stash them. I will tell you about stashes in advanced section later. But yeah, you just double click on the revision and you change branches super easily in the UI. And you can also look at the diff between two branches, for example, like that. So you right click and you click compare to local changes. So we will compare your local state to the revision that you clicked on, right? And I will see all the difference here. If there will be multiple files, I will be able to click on them and see. And if I have something added locally, it will be highlighted as green, and remove things will be highlighted as red, right? So done, and let's move forward. So show you that. Yeah, I have shown you fetch. They told you about automatic fetch. And yeah, when you do fetch, actually Git already downloads everything to your computer, but it just stores it in some hidden folder. I will also tell you about this folder in the advanced section. But yeah, when you do fetch, everything is downloaded already, and you can then switch between branches, switch to new remote things you have fetched without connection to the internet. Okay, so I'll talk about that. Yeah, we're already more than we have passed more than a half, so super, quite close to the end. Yeah, where can you see all the branches? Basically, when you fetch, you will see the branches here in the UI. You will see your local branches here, and you can see all the remote branches here. So you can open this remote thing. You can open the particular remote, which is origin by default, and then you will see all the remote branches here. So you will see what is available. And if new branch has appeared, and it might be somewhere here in the history in the past, you can't see it easily, then you just fetch the changes. This branch is downloaded to you locally, and then you will see this new branch to appear here under remote branches. That's it. You can also review the branches in GitHub UI. So you can navigate through several things here, and you have access to the code basically, so you can navigate through code. You can click on branches here and see like what branches do you have. And if some branch is finished and merged already, it's a good practice to remove it. I will show you how you do that, so that it doesn't add like trash to your repository. Okay, moving forward. Next thing is merge. So what do you do when you have finished your work? Let me show you. Basically, you do merge, and you can do this simply by merging in UI. Let me show you what you do. So for example, I want to merge this piece, right? And in this case, if I do this through UI, I go here in main, and I do right click on what I want to merge and click merge to main. Merge. And in this case, it by default creates a merge commit like that, and branches are just combined together visually. So I see that this thing was developed here, and then it merges, right? It's visually quite clear. And now if I push, I will change the state of main. In main, remote will be also changed. In this time, second user, when he fetches the state, will see the following situation. Like, okay, my code is already behind, right? And if he wants to merge his changes also, of course he can do just merge also. But in this case, I will show you what it will look like. In this case, it will look quite complex, like one more commit, 3 branches in parallel. So it's not the best way to do that. It's possible if you have not many branches and not many people working in parallel. But in such cases, usually we use rebase. I will show you what it looks like. And in order to show it, I will just reset the state of my local branch so that it won't have this merge here. Oh, and actually I have done the wrong merge. I've merged main into my feature, but usually we merge my feature into main when you finish work. But if we want to get the intermediate changes, like for example, get these changes to my branch and continue development with them, then yes, we can merge main branch to us. But yeah, I will show you what you may do in this case better, so that the history in Git will look better. So I do reset my feature to here, do hard reset. So I rolled back the state to where it was a minute ago. And now what I do is I do rebase. I will show you what rebase does. Basically, it moves my branch from here to here. So I press rebase my feature to here, submit, and see. Now my branch is moved here. Remotely is not yet here. So in order to change remote state, I do push. And if I do just push without force, it will say that I try to override the history. So after rebase, I do force push. And now state of the remote branch represents my local state. And now I can do merge in a prettier way. So I switch to main and I can merge this into main. But I will show you how you can do pull request now. So when you work in the team, usually you not just merge your change, but you pass review first. So and in order to start review, you go to pull request in case of GitHub, and it already suggests me that I can create a pull request for my feature. So for recent features, it just makes this suggestion. If the commit was not that recent, you can just press new pull request and select in what branch you want to do the merge and from what branch. And I want to do merge from my branch. All right, I want to remove this high, and now I press create pull request. Provide a name for that, provide the description if needed, and just create. So now you can share this link with your team, and they will be able to review. All the changes are here in files changed, so you see what's changed. They can write comments here, ask questions to you, and you will be able to respond to them. And once they agree with your changes, they just press approve here, right? Oh yeah, in this case I can't press approve because I'm the author, but yeah, if I will be a reviewer, another person, I will be able to press approve here, to select approve here and press submit changes, submit review. Okay. And in GitHub, I can by default merge request even without approval. You can configure it so that the approval will be needed. And you can also select the way of how you do the merge, but default way is to do this with merge commit. So I click merge here, and then when I fetch local state, I will see this branch merged, right? But the difference is that in first case, I just merged the branch, but in second case, I created a pull request and there was an ability to make review and ask questions and make changes if needed, if there were some bugs or flaws in the style. Okay, so that's how it works, like when there are no conflicts, right? I will show you what it looks like when there are conflicts. And by the way, at the moment I have fetched state on both users, but you may see that I still have this my feature here, which is local representation of this branch that was already merged. So my local branch doesn't change automatically if some forced changes were made or if it's not the branch where I am at the moment. So this branch is not needed now, and I delete local branches when they're not needed anymore. So I delete, and if this branch still exists remotely, there is an option to delete remote branch, and I can do that because the remote branch is merged already. And you can also delete non-used, non-required branches from GitHub UI also here. So you can press remove here on the branch that is not needed, and I don't need this one anymore, so I delete remote branch here. Okay. There is an ability to roll back the change for some time after you did it, but when I refresh the page, so yeah, the branch disappeared. And if I fetch the state, remote branch will disappear, but local one still is present. So in order to delete it, I delete it here. Okay, it's done. So now we have main, and let me show you what happens when we have a conflict. I will simulate it quite easily. I will add by friend here for a second user, and I will add by enemy here for the first user, and we'll commit it separately to, let's say, also to a feature branch. It will be enemy thing, and commit it and push. You can also configure Git Git client so that it will be pushing changes once you commit them, if you want, if it is more convenient to you. Okay, and now we'll create new branch. And by the way, yeah, I have cleaned branches for user 1, but user 2 still has local branches. And after I will fetch changes, I will see that this remote branch will disappear and this one, but local branch remains, right? Okay, and I see this enemy thing pushed from user 1, and I will create my branch here, friend thing, and we'll modify the same line of code from user 2. Yeah, I've already done that. Okay, and now I will commit it. And also push. And see, now two users have modified the same line of code in the same file, and we have a conflict. It will be visible when we will do a second merge. So let's say first user does the merge. I will do this just in the UI, but in your case you may do this through pull request. Okay, merging, pushing main state. And when I will try to merge second user delta, I will have an error. So let's say I would rebase this user state. In this case, during rebase I will get a conflict. If I try to merge, I will get a conflict during merge. So if I press merge now, I will have a conflict, but I will show you how it will look like in case of rebase. So I try to rebase friend thing to here, and Git says, okay, there was a conflict, right? And in the UI, it shows me this element here, which shows, okay, we're in the process of rebase, and I can abort it if I don't want, and I can resolve the conflict. I will show you how I will do that. And I see where we are, because we are rebasing all the commits from the branch, and if there will be multiple commits have the conflict, then you will need to resolve conflicts multiple times during rebase. If you do this through console, you will also be able to do all these things, but it will be quite hard to do in case of rebase, because you will know like what commands to use for each of the steps. In UI it's easier. So in this case I have the conflict, and the conflict is displayed in user2 repo like that. So we have these symbols, then we say, okay, in the head, which means in the head, which means in main, I have by enemy, but locally in my friend thing, in my friend branch with friend thing commit, I have this delta, and it asks me like what is more correct. So I can't keep it like that, and in order to resolve it, I need to decide like how the final state looks like by enemy and friend, for example, right? So I just decide how I merge it, and then I press resolve here, and I can check that conflicts are resolved here. If they're not resolved, I will see it as not resolved. And in the UI there is an ability also to resolve conflicts using this UI. I will show you what it looks like in the UI. So I will press abort, and we'll try to rebase again. So we'll get in the same situation, and now I will see this suggestion for the conflict resolution, and we'll have this exclamation mark here, which means that it's in the conflict state. And I can either select one of the versions here, or I can select to merge in external tool or merge and fork, and it will show me the side-by-side comparison, so that I will be able to select. But I usually do conflict resolution, if it's more or less complex one, in the code editor. So for me it's easier to do. So I'll do it like that, and the UI client will detect that I have resolved the conflict. And now I can stage it and continue rebase. So I press continue. It's instead of commit here. Okay. And now I see that my branch is rebased. The conflict is resolved. Though still local branch is different from remote one. So I do push and do force push in this case. And that's it. So the conflicts are resolved. Conflicts produce lots of misunderstanding and complexity when you don't know how to work with them. But if you know all the process, it's quite easy to resolve. And all you will think about is like what the code should look like in the end. So yeah, I've told you about this. Okay, one more thing. There is a thing called interactive rebase or interactively rebase. I will show you just how to call it in the UI. So you can either, now let me show you. Okay, I probably will need to do some change in order to show it to you. Okay, we'll do this from user one. We'll create a branch and we'll add a couple commits. New ones. Done, and one more. Okay, so I have my branch here, and let's say I want to rebase these changes to here. So what I can do is I can, instead of rebase, I can do interactively rebase, which will allow me to pick the revisions that I want to rebase, and I can select just several, not all of them, for example. And it may be needed in some cases, and if you will need it, just know that there is such a feature to pick commits that you want to rebase. So rebase not all of them. Okay, and it may also be that you work on some feature together with other developers. In this case, you will have like main feature branch and your personal branches. And from time to time, you will merge your changes in main feature branch. And you will also either use merge or rebase in this case. I recommend to use rebase if possible, because in this case, the history will be easier to understand. And then when you finish work on the entire branch, you merge it in main. Basically, that's what it looks like. Okay, I told you about merges in main and pull requests already. Okay, a couple more concepts from Git. One more thing is called tags, and tags are just textual labels that you assign to some revision. By default, each revision already has a textual label, which is its hash. It's a short hash, and you can also review its full hash here. So it's already a textual ID, let's say, that represents this revision, but you may also add a readable tag, for example, version 1 tag, and with some description here. And when you create a tag, you see it here, and tags can be pulled separately from the repository. So in this case, when I created it, I pushed it already. So this tag is pushed to remote repo, and I can fetch tags also. So see, here I have fetched the changes and I see a tag here. So usually we tag commits with release versions or some other meaningful things that we want to easily navigate through. And in the UI, we can see all the tags here. So when you work on branches are removed, feature branches are removed at some point, and tags are usually preserved for a long time. So these are tags. And one more helpful concept in Git is called stash, which is the following. So for example, you have some local changes. For example, here I have, let's say, one simple edit, and I don't want to commit it, but I want to switch to another branch to see what's happening in there. So what do I do in this case? If I just switch here, it asks me, okay, what do I want to do with local changes? And I can press stash and reapply local changes. But if, for example, this file doesn't exist in another branch, it won't work. It will produce an error if you do modification in the file that doesn't exist. And in this case, I usually use stash, which works like that. So I just press save stash and provide a name to it. And in the UI, it's represented as a separate commit or separate revision, but it actually is not a commit. It is not added to any branch. It is not pushed, and you cannot push it. You see it here in stashes, but it's removed from local changes. So you just saved this information as a commit, or in a way similar to commit. Now you can switch to another branch without any work with local changes. You can do what you want, and then get back to your branch, double click on stash, and it will be reapplied. So you just add it to this intermediate storage. Quite useful thing. Okay, so finished with stash. Yeah, we'll tell you about the bonus thing in a minute, and before that I will provide an intermediate summary. So I have told you about basic concepts of how to use Git and showed you how you can do each of these things in UI. So try to do it by yourself, try to create a repo, try to make pushes, pulls, and commits just to get familiar with all these things. You can do it in the same way, like create one repository, pull it into folders, and see what happens when you do different things. And then you will get this intuition and get familiar with the tool. That's it. And if you like this video, please press like and subscribe to my channel so that you won't miss new interesting things. Okay, so speaking about the bonus now. Data scientists often work in Jupyter notebooks, and Jupyter notebooks are textual files, though not the same as Python files. Let me show you what they look like. So I have this notebook somewhere. Okay, so I have this notebook. I will put it in the repo, for example, here. And we'll open the notebook in Jupyter first. We'll show you what it looks like. So here is it. Here is it. So here I install a package, then import it, get dataset from it. Here is the dataset. So I have a pandas table here. Then check some things, plot matplotlib graph, and then plot plotlib graph. Okay, we'll replot it. Yeah, here is it. And now I want to show you how these things look like in the file actually. So here is the contents of this notebook file, and it's a JSON. It contains an array for all these cells, and it contains both the code of the cell and its outputs. So for example, I see outputs here, and if outputs are big, they just take quite big space here, and here is the source. So that's what is written in the cell basically. And if I have plugins installed, for example, in this case I have a plugin installed to display execution time, I have them also put here in metadata. So I have this for all the cells. So what I will next show you is how like each piece of content is put here. So for example, these pandas table is put as HTML here, and I have all the contents here in a long set of lines. And then when I have this matplotlib graph, here is it, I have it as base 64 encoded string here. Also quite big, so it's binary. See? Oh yeah, it was somewhere here again. Let's get back to it. Yeah, here is it. So it ends somewhere, yeah, it ends here. But yeah, several screens of text for this small image. If image is bigger, you will have more text. And then for matplotlib graph, for this one, I have text, but quite a big piece of text in the output here. So see, all this thing is the output of the matplotlib, or of the plotly graph. So I have contents separately, like points, etc., etc. And it's okay if the graph is small, but if you have many points on the graph, like for example, thousands of points or 10,000 of points, it will take huge amount of space. And at the moment, it already takes like 3.9 megabytes, and the majority of that is that plotly graph. And I recommend not to push notebooks with outputs in Git, because it will be hard to review what you have changed. And basically, when people review the changes, they want to review what you changed in the code, but not review the binary representation of the graph, right? They can't read it in any case. And in order to commit the notebook, you do the following. You press cell, clear output, all output clear, yeah, here. And if plugins are installed, in this case execution timings, I press execution timings, clear all, and save. And now what I will see is that I will see quite a small text file. Let me show you what it looks like now. So see, no outputs, just 100 lines of JSON. It still contains some not important information like metadata or these things, but it contains the code. And also, and a good thing is that delta will be quite easily readable. Let me show you. So what I will commit, I won't commit these checkpoints. We'll ignore them for now, and we'll show you later what to do with them. Okay, so in your case, please provide meaningful commits. I will just provide a simple one for the sake of time. So it's committed now. And what will happen if I will change anything? For example, I will do what? I will shorten the data frame, right? So if I just save the changes, I will see a small delta here. It's not just one line, and it's easy to review. So actually you can review this during pull requests. It's not purely Python code, because we have these symbols here, but still you understand what is happening here, right? And it's easy to review. But if you put outputs back, you will not have a chance to understand what's happening here, right? So what is the change? A lot of lines are changed, lots of lines are changed. And if the graph is big, you won't be able to see it at all here. So client will say like, okay, I can't display it at all. You have too big piece of information, so I just can't display it. I will try to reproduce this state. Oh yeah, the data frame is small, so that's why it still presents the information. But if I will not cut the data frame, probably it will be too big. Let me see. No, still works, can tolerate that. Yeah, I will then probably do like that. Show you what it looks like for a really big graph. Okay. Okay, so graphs are messy now. Yeah, it says it's too big to be rendered, right? So it contains too many lines. So basically now it's 2 megabytes. Yeah, but yeah, the diff is too big. So I will roll back this thing. We'll remove it, and we'll remove this one. We'll put this one back. So that was the state I wanted to show. And in order to commit it, I do again cell, all output clear, cell, execution time is clear, save and checkpoint, And here is my small delta. Yeah, I imported pandas also. Cell ID was changed. It also happens sometimes, but it's just one line. And still I can understand what happened here. What happened? Not sure what I did. Okay. Yeah. And yeah, so Git is not developed for notebooks, but you still can work with them and commit them and review Delta. And if you want even more advanced view, you can look inside the Google Cloud Platform, and they have an ability in their Vertex API to store notebooks, and show Delta even with what was changed with 2 versions of images. So they have quite cool UI for that. But if you just want to store your notebooks in Git, you can do like that, clear outputs and then commit them, and it will work for you. Okay, and as I promised, a couple more advanced things to show you. And yeah, first one is how the information is stored locally for Git repository. At the moment, in modern version of Git, it's stored in one folder which is called .git. It's hidden, and it contains binary things here in objects, and they are grouped in like by cache prefix. And they also have like logs here. They have configs here, so you can actually open config as a text file and see all the things here, like what are the branches, what are the remotes. So it's stored here, and information about where your head is also here. See, so it's just some information. It's stored in quite plain way, except the binary, or except the cache files with the deltas. So that's the file. In older versions of Git, this Git folder was created inside each of the folders, but now it's just in the root. Okay. Then you can add gitignore file, which is helpful in case you want to ignore some files. For example, in this case, this IPNB checkpoints folder was created, and I don't want to commit it. So what I can do is I can add a file here, call it gitignore, and add the name of this folder here. And in this case, I will have gitignore file added, so I can commit it, but this IPNB checkpoints folder is disappeared. And gitignore is quite powerful, so you can not only ignore files and folders from immediate folder, but from subfolders also, so you can configure it quite flexibly. And you can also have multiple remotes in Git. So in this case, I have one remote, but I can add new remote. So for example, second repository will be not on GitHub, but in GitLab, the same repository, but like in different system. And I can add it, and I can push. When I push, I can select to what remote to push. So in this case, I have only one remote, but in case there will be multiple, I can select to what remote to push. And actually, your local repository can also serve as a remote if you will provide an external access to that. So somebody can push to your repository, or even you can push to your repository. It's also possible. It's quite a rare use case, but sometimes you may want to do that. So it's also possible. And yeah, that's it for Git. I told you about everything I wanted. If you have any questions, you can put them in the comment, and I will try to answer them. And yeah, improve your skills, get familiar with Git. See you soon.